Hello everyone, my name is Faizan Hussain. Today I am going to explain one of the most important tools used in big data systems, Apache ZooKeeper. In this presentation, we will understand what ZooKeeper is, why it is used, and how it helps in managing large distributed systems efficiently. Now we start with our first slide. I move. So, first is what is ZooKeeper? What ZooKeeper do? Apache ZooKeeper is an open source distributed coordination service. It provides a centralized management system that helps coordinate and synchronize different components in big data systems. It's a backbone technology used in big platforms like Hadoop, Kafka, HBase, and Solve. ZooKeeper makes sure that all parts of a distributed system stay in sync, even when they are spread across multiple servers. Key advantage Key advantages of ZooKeeper. ZooKeeper provides three main advantages. First, centralized management. It acts as single source of truth for cluster configuration and states. Second, it's an industry standard trusted by big companies like LinkedIn, Yahoo, Netflix. And third, it ensures high reliability by offering fault tolerance across multiple nodes in a cluster. Now we move next. The challenges distributed coordination. In distributed system, multiple processes often run at the same time. This creates problems like we see first race conditions, where two or more processes try to access shared data simultaneously. It is a race condition. Second one is deadlocks, where process waits endlessly for each other resources. And third one is inconsistent states. Inconsistent states where data appears different across nodes. ZooKeeper solves these issues by offering strong coordination tools, ensuring that all parts of the system work together smoothly without conflicts. Now we move to next. Now we see ZooKeeper hierarchical namespace, Z nodes. ZooKeeper organizes its data in a structure similar to a file system. ZooKeeper's structure is very similar to our Windows file system. The basic unit of storage is called as Z node. There are three types of Z nodes. First is persistent Z nodes. Persistent Z nodes stay in memory until we deleted it manually. And second type of Z node is ephemeral Z nodes. Ephemeral Z nodes exist only while the client is connected. Once it disconnected, they disappear. And third one is sequential Z node. Sequential Z nodes automatically get a unique number, which helps in queue management and distributed logging. This flexible structure allows ZooKeeper to handle different coordination scenarios effectively. Now we move next. Core features and guarantees for ZooKeeper. First is sequential consistency. ZooKeeper provides four important guarantees. First is sequential consistency. Sequential consistency updates happen in the same order everywhere. Now we see second. Second one is atomicity. Atomicity means every operation either completes full or not at all. No partial updates. Atomicity provides these things. And third one is single system image. All clients see the same data, no matter which server they connect to at which time. They show a single system image. Now, fourth feature of ZooKeeper is high availability. If one server fails, others continue working to leader election and replication. These features make ZooKeeper reliable for mission critical systems. These are the core features and guarantees of ZooKeeper we see. Now we move to next. ZooKeeper Ensemble Architecture. ZooKeeper runs on a cluster known as Ensemble. Typically, there are 3 to 4 servers to ensure high fault tolerance. But one server becomes the leader and handles all write operations, while others act as followers to process read requests and maintain synchronization. A quorum-based voting system ensures that updates are applied only when the majority of nodes agree. This structure allows Zookeeper to keep running smoothly even if 1 or 2 servers go down. This is a specialty of Zookeeper. You see leader node, follower node, consistent voting, replication flow, Zookeeper. This is all quorum voting system ordinarily. Now we move to next. Key uses, key use cases in big data. Now we see key use cases in big data. First is Zookeeper has several practical uses in big data. First one is configuration management. It keeps all nodes updated with the latest settings. Second one is leader election. Automatically select a leader if the current one is fails. And third one is distributed logs. It prevents multiple clients from modifying the same resource at the same time. Reliable mutual exclusion and synchronization primitives preventing concurrent access to critical shared resources. And fourth one is service discovery. Dynamic registration and location of tracking of service with automatic removal when service become unavailable. It helps application locate service dynamically and removes them when they are unavailable. Now we move next. Now we see real world impact of ZooKeeper and industry example. First we see LinkedIn. LinkedIn uses it in Kafka to manage broker election and consumer synchronization. It uses ZooKeeper for coordination, managing message broker, election, and consumer group synchronizations across massive data pipelines. And second example is Netflix. Netflix relies on it for its subsidy discovery and automatic failover in their microservice architecture and configure management and across microservices. Fourth one is Hadoop and YRN. Integrate ZooKeeper for resource manager, high availability and job trigger condition in large scale batch processing. This example shows zookeeper importance in real-world large example. Now we move to next. Now we see best practices and deployment tips. When deploying a zookeeper, a few best practices should be followed. Always use odd number of nodes, like 3 or 5 proper quorum and fault tolerance. Lightweight data. It is store only lightweight data, not large payload to keep performance high. And third one is session monitoring. In session monitoring, monitor session timeouts and event watchers to ensure system healthy. And fourth one is independent updates. Update Zookeeper independently from other applications to prevent cascading failures. Now we move next. Why Zookeeper matters in big data? Now we see simplifies complexity, abstracts integrate distributed coordination, challenges into manageable primitives. To summarize, Zookeeper simplifies the complexity of distributed combination. Second one is enables scalability, supports reliable fault tolerant and ecosystem spanning thousands of nodes globally. Third one is foundation layer. For powers critical services like Kafka, HBase, Sol, and modern distributed system. Fourth one is mastery requirement, essential knowledge for building robust production, great distributed system. To summarize, Zookeeper simplifies the complexity of distributed coordination. It enables scalability and fault tolerance across the thousands of nodes. It's foundational layer for major distributed systems like Kafka, HBase, and Sol. Mastering Zookeeper is essential for anyone aiming to design robust production-grade distributed applications. Thank you. Thank you so much for watching this presentation. I hope you know now have a clear understanding of Apache Zookeeper, its architecture, features, real-world applications, and how it works and implementation. Once again, I am Faizan Hussain. Have a great day. Thank you so much.